So today we'll start with the discussion on IPv4. Okay. So till now, whenever I was doing the theory, whenever I was explaining the theory part on the networking concept, I was writing some IP addresses, some random IP addresses to the PCs. When I did practical for the spanning tree protocol yesterday, I gave some IP addresses to the PCs, right? So we are going to discuss about those IP addresses in today's class and probably next few classes as well. So IPv4, we know that IPv4 stands for Internet Protocol version 4. Okay. So yes, if it is version 4, yes, there have been version 1, there have been version 2, there have been version 3, there was a version 5, and there is a version 6, which we currently use as well. But to be very honest, I do not have any knowledge about what were these versions, why were they rejected, or were they not fruitful enough, etc. All that thing I'm not aware of it, and hence I'm not going to go into that discussion. However, we know if it is version 4, obviously there were older versions, probably they did not fit into the requirement of what the network needed, right? That is why version 4 had a better chance of living up to that expectation, and that is why we have version 4, IPv4. Similarly, we have IPv6 as well. There was an IPv5 before IPv6, but again, that did not suit well enough to the growing technologies and growing need for IP addresses, and they made some changes into IP version 5, and then they brought IP version 6. So anyway, before we jump into the discussion or what trying to understand what IP protocol version 4 is or IPv4 is, let's first understand what basically it does. We have been always saying it's an address. Yes, it is an address. Okay. And address, just like our home address. Okay. But as our home address is unique, IPv4 address is not unique. It looks like an address which is written in the format of A.B.C.D, something like this. It's written like this in this format, right? A.B.C.D. Now 10.1.1.1 like this. Now these dots that you see, okay, they separate different numbers. Okay, they separate different numbers, and these separations or the the numbers between each dots is called as an octet. Okay, so we call this as a first octet, second octet, third octet, fourth octet. Okay, why is it called as an octet? Because the number between, right, the number between the dots or the number in these octets, okay, is actually an 8-bit number. Okay, so when you convert 10 into an 8-bit binary format, you will get some value. If you convert 1 into 8-bit binary format, you will get some value. Similarly, these three octets. So 8 in Roman form, it's called as octa, and that is why it's called as an octet. Right. So each number is an octet, and that is why we call it. That is why we call IPv4 having 4 octets. Right. So 4 octets into 8 bits, right, which makes it 32 bits. So your IP address, any IP address that you see in the network, is a 32 bits IP address, 32 bits long IP address. Okay. Now, IP addresses have been separated into different classes. You have 5 classes of IPv4 address. Now we are talking only for IPv4. We are not talking IPv6. We are only talking about IPv4 addresses, right? So IPv4 addresses have 5 different classes. Okay. So class A, class B, class C, class D, and class E. These are the 5 different classes of an IPv4 address. And how are these basically divided? They are basically divided through some numbers, and they are divided based on the number that is in the first octet. Okay. So if the IP address starts from number 0 up till 126, right? This first octet over here, right? If it starts with a number between 0 and 126, it is called a class A IP address. We are not considering the last 3 octets at all. We are considering only the first octet. So like this IP address 10.1.1.1, right? It is a class A IP address. I can also write any IP address, for example, let's say 52.254. Okay, 0. Let's say 72. Okay, this is a class A IP address because the first octet is between 0 and 126. That is what it is called as a class A IP address. Okay, and as I said, every octet is an 8-bit number, right? So if you write from 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, when you write like this, the maximum number that you can go, right, using these 8 numbers is from starting from 0, and you start converting each bit in the combinations of ones and zeros. You can get numbers from 0 to 255. So at any of these octets, the numbers can be starting from 0 up till 254 in any of these octets. But as I said, we are not considering these octets to find out which class do they belong to. We are only considering the first octet. And in the first octet, if the number is between 0 and 126, it is called as a class A IP address. Right? Then class B IP address, it starts from 128 okay, till 191. So an IP address, if I write it as 172.168.1.1, this is a class B IP address because the first octet is between 128 and 191. The next is 192 to 238. Okay, sorry, not 238. I'm sorry, 223. Okay, 223. So if I write an IP address, say 200.10.11.12, something like this, this is a class C IP address because the first octet is 200. The next 224 till 239. So most of our routing protocols have IP addresses or their multicast IP addresses start from 224. So for OSPF, we have a multicast address of 224.0.0.5 and 6, right? So the number is between 224 and 239. That is why it's a class D IP address. The next is from 240 till 255, right? These are called as class E IP address. Now, from a networking point of view, we will always see these 3 classes being used majorly. These 3 classes being used at every on every PCs, on every routers, or on a layer 3 switches. We will see these 3 classes being used, right? Class D is called as a multicast IP addresses. Right? All your routing protocols have a multicast IP address which is between 224 and 239. Class E is called as a reserved, or you can also call it as an experimental class. Okay, so these are never used in real time. So you will come across ABC IP addresses frequently. Class D IP address you will always see with a routing protocol, right? or when we are working with a multicast is a separate technology. So when we are looking into multicast like traffic, we will see this IP address, this range of IP address. E, you will never ever see. It's an experimental, it's a reserved I class IP address. Okay. Now, a IP address, an IP address, it can be any class A, class B, class C. So as I said, we are looking into first three classes because they are majorly used: class A, class B, and class C, right? So these three classes of IP addresses or any IP address, any IPv4 address is divided into two parts. Okay. The first part is called as the network part. Okay. And the second part is called as the host part. Okay. Or we can call this part as network octet and the second part as host octet. All right, network octet and host octet. So each of these classes that we saw, class A, class B, and class C, they have different network octets and different host octets. Right? And we know that there are 4 octets in an IP address, right? So for class A, right, you have, let me write this as first octet, second octet, third, and fourth. Okay, so you have 4 octets for any class, right? So, but for class A, the first octet of a class A IP address is called as the network octet. The rest of the octets are called as the host octets. I will explain you the meaning of network and host in just some time. In a class B, the first 2 octets are called as network octets. The last 2 octets are called as host octets. For class C, 3 octets are network octets. Only the last octet is the host octet. Okay. Now, what is this network octet and host octet? What do we mean by network octet and host octet? Let's try to understand it from a real-time perspective. Okay, or an analogy. Right? So we know that when IPv4 was being created, okay, IPv4 is created by an organization called as IANA. Okay, I forgot the full form. I think it's called as International Authority for International Authority Numbering something. I forgot.
Internet Ascent, Internet Ascent Network Organization, I think authority.
Authority, something like that. You can Google. It's not important from an interview point of view. Just Google it. IANA is the organization which creates IP addresses and which also assigns IP addresses to everyone in the world. Okay. So if your laptop, if your phone, if your smart TV, if your smartphone, even your smart fridge, nowadays we have smart fridges, we have smart washing machines also, right? Anything that is connected to the internet, if they have an IP address, it is because of this organization, IANA. So now let's consider how, let's think of, or let's understand how do they assign IP addresses. Okay. So whatever scenario that I'm going to tell you is a very hypothetical scenario. Again, I'm repeating, it's a hypothetical scenario, right? But it is a good way of understanding the network part and the host part for any IP v4 classes. Okay. So what IANA did is that it okay, so we have different continents in the world, right? So we have Asia over here, right? And we have Australia at the bottom. Then we have here Europe, Africa. Then we have North America and South America. And we have Antarctica. So I'm not, yeah. So we have these 7 continents, right? Now, what IANA thought, okay, again, as I said, it's a hypothetical, analogy that I'm giving you. So it said any country in Asia, will have an IP address that will start from, let's say, 172. So it said all the countries in Asia will have an IP address that is going to start with 172. So what happened? It can be any country. India, okay, India, Russia, can be China, okay, it can be Pakistan, it can be Sri Lanka, any country in Asia. All those countries in Asia will have an IP address that is starting with 172. So what happened? All of them share this 172 together. All of them share this 172. Correct? Please keep this mind. Sharing, meaning they have a common number, 172. Right? So they said we will give 172 number, or the starting number 172, for all the countries in Asia. So now let's concentrate from Indian perspective. Now the internet service providers in India, right? So this is for India. Okay. Now, so the service providers in India, they said we will give different numbers for different states in the second octet. 172 is the first octet. Now, in the second octet, for different states, Indian service providers thought we will give different numbers for different states. Okay, so let's say as I said, I live in Maharashtra. So they said 172 dot the next number. Let's say 22, for example. 22 is for Maharashtra. Okay, so any IP address or any user who belongs to Maharashtra will have an IP address that starts with 172 and 22. So for 172, it was for all the countries in Asia. 22 is for all the users inside Maharashtra. So it can be Pune, it can be Bombay, it can be Nagpur. There are so many different places in Maharashtra. All of them will have an IP address 172.22. Okay, then the local service provider said for each cities, we will give different number in the third octet. Again, repeating, the local service providers said we will give different numbers in the third octet for different cities inside Maharashtra. So let's say 172.22 dot the third octet. Let's say it is 11. 11, they said we will give it to Pune. So all the users in Pune now will have an IP address starting from 172.22.11. So all the people in Asia, right, will have an IP address starting from 172. All the people in India, okay, for all the people in India also will have an IP address starting from 172. Then all the people in Maharashtra will have an IP address starting from 172.22. Then in Pune, all the people inside all the people in Pune will have an IP address starting from 172.11. Okay, now imagine, again, as I said, it's a hypothetical situation. Imagine there are only 255 people in Pune. There are only 255 people in Pune, for example, right? So now what will happen? The first person in Pune will get an IP address of 1. Second person in Pune will get an IP address 172.22.11.2. The third person will get .3, fourth .4, .5, like that up till 255. So 255 people in Pune are now getting IP addresses from 1, 2, 3, 4, 5. Okay. So now think from Pune people's perspective. Their first 3 octets remains the same because they belong to Pune. The only octet that is changing is the last octet, 1, 2, 3, 4, 5, like that, because they are different users. So as I said, think from people who are living in Pune. Their first 3 octet remains the same, right? Then think from city's perspective. Okay, so for people who are living in Bombay, they may have a different number in the third octet. Let's say it has 12, for example. Okay, I'm erasing these things. For people in Bombay, okay, they have an IP address 172.22. Instead of 11, they have 12, right? But for Pune people, it is 172.22.11. So think from city's perspective. From city's perspective, their first 2 octet remains the same. Correct? From city's perspective, their first 2 octet remains the same. Then coming from the state perspective, right? For Maharashtra, it is 22. As I said, for Maharashtra, the second octet is 22, 172.22. Right? Let's say for people in MP, it will start with 172. For example, 23. For people in, let's say, Tamil Nadu, they will have 172.24. Okay. So from state perspective, their first octet is common. So are you able to visualize this pattern? Right. So if you see from different states perspective, the first octet is same, 172. They all different states in India will have an IP address starting from 172. Right. Sorry. In India, all the IP addresses will start with 172. Right. Then the second octet will have different numbers based on different cities. However, their first octet is common because they belong to India. Right. Then based on cities, they will have different numbers in the third octet. Right. So based for Bombay, it is 12. For Pune, it is 11. However, the first 2 octet remains the same because they belong to India and each cities belong to Maharashtra. Right. Now, in the fourth octet, for different users, let's say for here, we have 1, 2, 3, etc. For them, the first 3 octet remains the same because they belong to India, they belong to Maharashtra, and they belong to the city of Pune. So what is happening? You are different users. However, your first 3 octet remains the same. So now coming back to this perspective of IPv4, whichever octet, these octets that are same, in an IPv4 perspective, the octets that are constant are called as network octets. The octets that keep on changing, they are called as host octets. They are called as host octets. Again, I'm repeating, the octets that remains the same in an IP address, they are called as network octets. The octets that keep on changing, they are called as host octets. So this is always constant and this is variable. Okay. Now each classes in IP addresses, IPv4, that is class A, class B, class C, they have different set of network octets and they have a different set of host octets. So if I go back to our matrix over here, class A has only first octet as network octet, meaning any IP address that belongs to class A, meaning class A, we know that the IP address starts from 0 up till 126, right? So I can write any IP address from 10, let's say 10.1.1.1, or I can write 11.1.1.1, or I can write it as 126.1.1.1. So what is happening here is that for the IP addresses or for the users belonging to class A IP address, for 10.1.1.1, 10 is constant. 10 is constant for all those users who belong to the 10 IP address. Which will keep on changing? These three octets. The host octets in class A, which are the last three octets, they will keep on changing. So 10.0.0.1, 10.0.1.1 or 10.100.100.100, all of them belong to the same network octet. That is 10. Similarly, any IP address in class A will belong to the same network of the first octet. Let me repeat that statement again. Any class A IP address will belong to the same network octet. That is the first octet. So if I write, let's take the example of 126. Okay, 126.126.126.126, or I can write it as 126.10.11.12, 126.0.0.1, or 126.1.1.1. All of them belong to the same network of 126. The only thing that is changing in class A IP address is the last three octets, which we call them as host octets. And this is the network octet. So network octet for class A is the first octet and the host octet is the last three octets. Only the host octet will keep on changing. This is true for every classes. Host octets will change, network octet will never change. Meaning that all these IP addresses belong to the same family of 126. All these IP addresses here, they all belong to the same family of 10. All these IP addresses belong to the same family of 11. So it's basically like a surname. Or in order for you to give even a better idea about this, consider like let's say, hey Mohit, can you tell me your house address, proper house address, whatever you write, or just give me random. Okay, let me. Okay, flat number 123. Okay, flat number 123. And this is, let's say, building ABC, right? Building ABC. Let me write it as street XYZ. Okay. Then area, me DEF. Okay. And then we'll write the city. Okay. Pune. And I'll write Pune and state. Right. So here, consider this house address. Flat number 123, building ABC, street XYZ, area DEF. city Pune, and state Maharashtra. Okay. Now, for anyone who is living in building ABC, right? So my neighbor will have a different different address. The only thing that will change is this flat number. Correct? The rest of the IP address will remain the same. Right? What is my neighbor probably will have 124 or 122, right? Or if that neighbor is living on the next floor or a floor below, they will have a different flat number. However, the rest of the address will remain the same. So what is happening in this house address? In this house address, what is happening? The host part. This is the host part. Rest of them is the network part, because as I said, it remains constant. It is not going to change, because all of us live in Maharashtra, all of us live in Pune, all of us live inside area DEF, all of us live in the street XYZ, all of us live in the building ABC. However, our flat numbers are different. So what is happening? The only thing that is changing between my address and my neighbor's address is the flat number. The rest of the thing remain the same. So as I said over here, so the rest of the my flat, this is my flat number. This is my flat number, and this is the rest of the address. This is the rest of the address, which is same. So in an IP address, the part which is always constant is the network part. The part which keeps on changing is the host part. Okay, any problem understanding, Krishan, Mohit? Any problem understanding this network part and host part?
No, sir.
Krishan, I remember you said you are pretty new to networking. Is any problem understanding this part? Okay, fine. Now, for every classes, you have different set of network parts and you have different set of host parts. So for class B, the first two octets will remain the same. The last two octets will keep on changing, right? So if I write an IP address from class B, 172.168.1.1. Okay, so this is a class B IP address. So what is going to happen? These two octets will remain the same because they are the network part, right? So 172.168.0.1, 172.168.0.50, 172.168.1.50, or this can be 254.254. It can be 30.31. It can be 4.3 or 3.4, anything. So here what is happening? The first two octets remain the same. The last two octets keep on changing. That is called as a host part in class B. The last two octets are called as the host octet. The first two octets are called as the network octet. Similarly, for class C IP address, the first three octets remain the same. So 192.168.1.1, right? This three octets will remain the same for class C. So 192.168.1.2.3.4.5.6, anything, right? Their first three octets will remain the same. That is called as the network part. The last octet, which is the host octet, will keep on changing. So in a simplest form, as I said, the network octet is constant. The host octet is variable. Again, it depends on which class are we using, right? So here is that matrix where how many network octets are there in each different classes. Okay. Any question, problem understanding this part? Anyone? Now, okay, give me a minute. Okay, so I will be sharing this PDF with you guys. Okay, so you can find it on the. I'll share this in the chat. Now, so as you can see here, as I mentioned, class A starts from 1 to 126, class B is 128 to 199, class C is 190 to 223, 224 to 239, 239 is class D, 240 to 255 class E. You can see reserved or experimental, multicast. All these are unicast IP addresses. And as I said, we would be using these three classes majorly. And just for multicast purpose, we will be using the class D. And you can see here, right? So class A, the first octet range is 1 to 126, 128 to 191, 192 to 223 for class A, B, and C respectively, right? Now leave this part for now. Okay. So you can see octets in network part in class A is 1 octet. For class B, it is 2 octets. For class C, they are 3 octets, right? Now, network part and host part. So in class A, you have 3 host octets. Class B, you have 2 host octets. And class C, you have 1 host octet. Right. Now, before I jump to the further discussion, okay, so let me just give you or show you an example of how a class B IP address may look like. So you can see here, okay, forget this. This is not what I want to show you. Okay, now here is the most interesting part that we should be understanding. When we are trying to understand IPv4 subnetting or addressing, this is what first we have to understand. For all the classes, okay, before even I jump there, the computer, okay, when I write any IP address as human being, when I write an IP address, for example, let's say 10.1.1.1 or 172.1.1.1 or let's say 200.1.1.1, okay, me being a human, I can easily understand that this is class A, this is class B, and this is class C, right? By looking into the first 3 octets, it's not first 3. By looking into the first octet of any IP address, as a human, we can understand this is class A, class B, and class C. But these IP addresses were not designed for us. They were designed for networking devices. They were designed for computers, routers, switches, servers, right? Now, for them to understand what is class A, what is class B, what is class C, these numberings and these patterns is not useful for them. Okay, that is not useful for them. Okay, because they understand only binary part, right? All our electronic and electrical devices, in the end, if you go deep at their, even at their, chip level, right? The signals, the electrical signals that they send is they're basically electrical pulses, right? If a pulse goes, we consider as 1. If there is no pulse, we consider as 0, right? So basically, they understand only these 2 binary digits, 1 and 0. For them, it is absolutely difficult to understand 10, 172, 200, let alone classes, right? They cannot understand these classes. They can understand only binary numbers. So for any networking device, what we did, we made it easier for them to understand what are these classes. So let's say if I assign this IP address to a PC, for example, okay, the PC should be intelligent enough to find out which class does it belong to. And how does it do? It does it with something called as the address mask. We created address mask for this purpose so that the networking devices can understand which class of IP address are we talking about. Okay, so for each of these classes, class A, class B, class C, we have different address mask. Okay, now, as I said, in class A, first octet is the network octet. So what we designed is a address mask where the first octet of an address mask is written in this form, 255.0.0.0. So always an IP address is followed by an address mask. Again, I'm repeating, an IP address like this, class A IP address, is always followed by an address mask, which is written in this format. It is also written in the same format that you write an IP address, 4 octets, right? A class B IP address is written with an address mask in this format, 255.255.0.0. And class C is written as 255.255.255.0. Now, this 255 denotes the network part, and these zeros denote the host part. Okay, so you just have one single octet of 255. You have 2 octets of 255. That means it's a class B. If you have 3 octets of class, if you have 3 octets of 255, that means it's a class C. We know that in class C, you have 3 network octets. These 255 tells you the network octets. How many network octets are there? So the first octet, second octet, and third octet have 255. That means it's a class C, because we know that in class C, you have 3 network octets. Similarly, in class B, you have 2 network octets, and thus we have 255.255. In class A, you just have 1 network octet, which is that is why you have 255 over here. However, again, the question comes, 255 is a number. How can a networking device understand 255? It only understands ones and zeros, right? That is why whenever we write, as I said, all the numbers, all the IP addresses that you type on a networking device, eventually they will convert it into binary format. They will convert it into a binary format. So if you convert 255 into its equivalent binary format, you will get 8 bits of 1. 1, 2, 3, 4, 5, 6, 7, 8. The rest of them are 8 bits of zeros. I'm not writing 8 bits of zeros over here. I'm just writing 0, 0, 0. Okay. In class B, you will have 8 bits of ones in first octet and in second octet. 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 0 dot 0. Similarly, in the for class C, you will have 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 0. So reading these numbers, these binary numbers, any computing device understands how many network octets are there, how many host octets are there, and based on the network octet and host octet, it finds out which class does this IP address belong to. Clear? Any problem? In order to even better understand it visually, I'll show it over here. So you can see here, for class A, right? As I said, any IP address that I write of class A, 11.11.11.11, I will always write this IP address along with its equivalent address mask, that is 255.0.0.0. A computing device will never understand this IP address. It will only see this address mask and it will see 255. It will convert it into its binary form. So when it converts, it will see all ones in the first octet, then 0, 0, 0. So looking into the address mask, any computing device or a networking device will understand that 255, there are only 8 bits of 255. That means 8 bits of 255 is belongs to the first octet. So that means this is a class A IP address. If I write 172.168.1.1 along with the address mask of 255.255.0.0, a networking device will convert it into its binary form, which will correspond to the first 2 octets. And it will understand that this IP address is a class B IP address. Similarly, for class C, you have 255, 255, 255, 0. Each of these octets, they correspond to the octets in the IP address, and hence any computing device will understand that this IP address belongs to class C. So as I said, networking devices, they do not understand IP addresses. They understand the address mask. Based on the address mask, they will find out which class does this IP belong to. Clear? Any question?
Lakshya, just out of curiosity, I just wanted to know, IP address will never start from 0, right?
No.
And if then why we give the default route as 0.0.0/0?
Okay, that is a special exception. Okay, that is a special exception where it has been designed. 0.0.0.0 was it's not a part of IPv4. It was a specially designed concept. Okay, it's a specially designed concept for routing, not for IPv4 address. You got my point? 0.0.0.0.0.0.0. This is the IP address. This is the address mask. Okay. If you think from an IP address perspective and a address mask perspective, these are completely wrong. But from a routing perspective, as I said, these were specially made for routing, not from an IPv4 addressing schema perspective. Okay, and that is why this is a special case where a networking device has been computed or has been designed. If it reads 000,000, it understands it's a default IP route. You cannot assign 000,000 to any networking device, can you? No. It's not used as an IP address, but it is used mainly for routing. Got my point?
Yeah, okay. Thanks.
Yeah. Any other question? Krishan, Mohit? कृष्ण, आपको मेरी आवाज आ रही है? आप सुन पा रहे हो?
आ रही है।
समझ में आया? कुछ डाउट है इसमें?
नहीं, अभी कुछ नहीं है वैसे डाउट।
ठीक है, थैंक यू। Okay. Now, one more thing we have to understand, that your address masks, as I said, any networking devices, it can be a computer, it can be your laptop, it can be your smart TV, it can be your smartphone, a printer, an IP printer, okay, that is connected to the internet, right? Or which is connected to the LAN, a server, okay, or a data center or anything, right? If it wants to understand the network part and the host part, right, there are some criteria for it also. Okay. So if computing devices or networking devices, they want to understand the network part or the host part in an IP address, there are some rules that is set by us as well. There are some rules for us also. Okay. So please remember, a networking device always understands the network part and the host part based on the number of ones in the address mask. It always sees 1 as network part and it sees 0 as host part. So you can see in this diagram that the network part contains all ones, the host part contains all zeros. Similarly, for class B, network part contains 1, host part contains zeros. Class C, network part contains all 1, host part contains all zeros. So if you have any number which has, let's say, 1 1 1 1 0 1 1 1, this is not an address mask. Any networking device will never understand or never see this as an address mask. It will see this as a normal number, never as an address mask, right? And if you have all zeros, right, it will not count this as network part. It will never count this as network part, but as a host part. It will count this as a host part. It won't even count it as a host part, but what I'm trying to say is it can never understand this as a host part nor as a network part as well. So the condition for address mask is also that all your network part, if you are writing an address mask or if you're choosing a number, address mask number, right, all in your address mask, all the ones should be on the left side of your address mask. All the zeros should be on the right side of your address mask. So you can see here on class A, all your ones are on the left side, all the zeros are on the right side. In class B also, all the ones are on the left side, all the zeros are on the right side. Class C, all the ones are on left side, all the zeros are on right side. There is no combination of ones and zeros, 1 1 1 0 1 0 1, etc. There is no such combination in the address mask. Address mask, not IP address. Address mask. As I said, with the address mask only, your networking device will find out what is a network part and what is a host part. So the condition for a networking device to find out which is a network part is that every number in the network part should be 1 and every number in the host part should be 0. That is how a networking device finds out the network portion and the host portion in an IP address. Clear? Any question? Okay. Now you may ask, why? As I said, it is an octet. It is an octet. We can have any number from 0 to 255, right? 1, 2, 3, 4, 5, 6, 7, 8. I can have any number from 0 to 255. 255 is all 1. 1, 2, 3, 4, 5, 6, 7, 8. right? So I can have any number starting from 0 up till 255. Why is it that if what if I have a number which is like 0 0? Will that be counted as a network part? No, it will not be counted as a network part. So whenever you are writing a address mask, you should choose a number where all the ones are on one side and all the zeros are on the other side. Meaning all the ones are on the left side and all the zeros are on the right side. So you have to choose such address mask. We'll talk about choosing the address mask later, but I'm trying to explain you this part. And what are those numbers? Let me go back. Can I find those numbers? Yep, here. So you can see these are the only values you can choose for an address mask. Starting from left hand side, 1, then 2 ones, 3, 4, 5, 6, 7, and 8. You can see all your ones are on the left hand side and all the zeros are on the right hand side. And people who are already aware of IPv4, you guys know that these are the numbers that we choose. And now you know why. Why are we supposed to choose these numbers only? Okay. Now, coming to the IP addressing few things. What's the time? Now, for any class A, class B, or class C, okay, let me write that down. Class B, class C, and their address mask as 255.0.0.0, 255.0.0.0. This is 255.255.255.0. These are called as the default address mask. These are called as the default address mask for each of these classes. Okay. So if I write, okay, let's say if I write 10.1.1.1, and if I do not write the address mask over here, if I keep the address mask as blank, any networking device will think automatically, because they have been programmed. They have been programmed to understand the IP addresses now as well. So they will automatically assume that the address mask is 255.0.0.0. Earlier, they did not have this capability to understand that this is a class A IP address. Now they have been programmed. If they see a number between 0 to 126, they will automatically, and if there is no address mask written after this IP address, they will automatically assume that the the address mask is 255.0.0.0. Okay. So now when I write an IP address, as I said, 10.1.1.1, right, with an address mask of 255.0.0.0. So what significance does it have? As a network engineer, we should immediately understand, what does this mean? What does this mean? Okay. So whenever a network engineer sees such an IP address, he should be able to calculate the range of IP address that comes with this IP address. Range of IPs. We should be able to find out the range of IPs. Okay, range meaning what is the start of this IP address? Where does it start from? Right, and where does this IP address range end? Okay, the whole purpose of creating an IP address was to find out basically the range of IP addresses. Okay, where does it start, where does it end, etc. As a network engineer, we should be able to find it out. Okay, so now what basically happens, as I said, in a class A IP address, the network octet remains the same. The rest of the 3 octets that are the host octets will keep on changing, right? So here, this IP address 10.1.1.1 will start from 10.0.0.0. It will start from 10.0.0.0. Then the next IP address would be 10.0.0.1. The next 10.0.0.0.2. Like this, it will go up till 255. 10.0.0.255. As I said, it's an 8-bit octet. So after 255, you can only have numbers from 0 to 255, right? So after 255, it will go to the next octet, where it will be 10.0.1.0. Then next would be 10.0.1.1, 10.0.1.2. Like this, it will go up till 10.0.1.255. Then once that is over, it will go to 10.0.2.0, and it will go up till 10.0.2.255, like this. And this will go up till where? It will go up till 10.0.255.255. So now we have come to an end of 255 over here. This is where it will jump to the second octet, 10.1.0.1. Then 10.1.0.2. Like this, it will go up till 10.1.0.255. Right. So where will this end? It will end at 10.255.255.255. So your IP address range, right, for a class A IP address with this address mask is huge, is extremely huge. So your IP address starts from 10.0.0.0 and it goes up till until each and every number in this octets, in these 3 octets, go to 255. That is the range of your IP addresses in class A. Class B will have a different range of IP addresses because we have less host octets. In class C, we have just 1 host octet, so the IP address range is also very less in class C. So that is what is mentioned in this here, right? Leave this part, you will be confused. Leave this part. Okay, so you can see hosts per network. You have 2 power 24 minus 2 hosts in class A. So we saw 10.0.0.0 up till 10.255.255.255 was the IP address range, right? Then in class B, because you just have 2 host octets, you have 2 power 16 minus 2, and in class C you have 2 power 8 minus 2. Why is this minus 2? I'll explain in just a minute. But any problem understanding the range of IP address? Krishan, Vivek?
No.
No, sir.
Now, why is there a minus 2? We just saw there was a minus 2 everywhere. Minus 2, minus 2, minus 2. What is this minus 2? So, in every class, you can see 0, 0, 0. I cannot assign this IP address to anyone because 0 is not a number. Because 0 is not a number, 0, 0, 0 in host octet cannot be assigned because basically it's nothing. So what is happening? One IP address is lost. Second, this one, 255.255.2.255. It is called as a broadcast IP address. Meaning if your host octets, okay, please remember host. If your host octets have all 255, that means it's a broadcast. Broadcast meaning if I send a message, it will be sent to everyone. If it is sent to everyone, all of them cannot have the same IP address, right? Your house address and your neighbor's house address cannot be same, correct? That's the basic funda, right? So 255.255.255 is if I send a message at 255.255.255, it means it will go to everyone. If it goes to everyone, I cannot assign this IP address to any person or any user. So this IP address is also lost, right? So this 000 IP address and this broadcast IP address are the two IP addresses which cannot be assigned. Because they cannot be assigned, it is minus 2 over here. Similarly, the broadcast IP address and the first IP address with 00 in class B cannot be assigned. That is why it is minus 2. In class C also, the first IP address which is 0 and the last IP address which is broadcast 255 cannot be assigned. So minus 2, and minus 2. Clear? Any question? Understanding the IP addresses. In today's class, I just explained what is network part, what is a host part, and how computing and networking devices understand what is a network part and what is a host part to address masks. Okay, I'm going through all this effort just to explain you subnetting in the next class. Okay, any question till now? All right. So I'll stop the class here.